All right, you can remove those. Hello, folks. So another Incus OS live stream. As mentioned on social media, I'm gonna the next few ones are gonna be a bit more focused, specifically around one very large piece of work that we have on Incus OS to just make it so much easier for everyone to deploy. So, as usual, I'm gonna start by just going through what happened over the past week or so. In this case, actually 2 weeks, since there was an Incus release last week. So the last live stream covering Incus OS work would have been on when is that? The 19th of February. So let's go look at everything that happened since. All right, so I need to go a bit further back, probably, or just a few days ago at this point, last week, and 2 weeks ago. Okay. And was it 19th, was it? Yeah, 19th was that. Okay, so that's 19th. Let's just go look tiny bit further. 2 weeks ago, still 19th. And where is that getting us? What day is it? 16th. Okay, we're getting there. Cool. Flasher tool, merge on 19th. Okay, so that's kind of the cutoff point as far as where to start looking at everything that happened in Incus OS. It looks like we probably had, yeah, there was a new version of Golang CI lint triggering a bunch of new fun warnings and stuff, so just cleared all that stuff. That's still more of that. Yeah, that's basically all fixing CI, linter feedback. So anyways, that's fine. I think I covered that actually in the last stream, yeah. The UTM instructions, so that was before the live stream. Then added, I think during the live stream, I was working kind of in parallel on adding the missing firmware for the Intel NPU. So that's that part that landed. Then that's what actually happened during the live stream last time, was adding the debug functions on applications. So that's been all added. And then that gets us to what landed afterwards. So dealing with some weirdness around some of the secure boot handling, with multiple subsequent OS updates without a reboot in between, leading to bad measurement within the TPM. So we fixed that. Then bumped some of the dependencies. More of the dependencies got bumped. Updated the instructions to cover ESXi as well as Reach Center for like a platform you can install Incus OS on. More updates. Like when we see all of those, what happens is that we were actually quickly iterating on either Migration Manager, Operation Center, or other components. So we're pushing new Incus OS builds out without actually changing anything to Incus OS itself. So that's when you see just those two commits back to back. It's what it meant. It's effectively, we wanted like one build a day to pick up some external changes, and that's what that looks like. Then we landed, finally, that took a while, the support for Multipath on the root disk. Not something that's going to impact really, I don't think anyone in this live stream, most likely not really anyone watching on YouTube. But there are some enterprise environments using Incus OS where the servers themselves don't have any local storage whatsoever. Instead, they use fiber channel with a SAN, and they get a small volume to act as their root disk, and then additional storage to act as the storage pools. Those root disks, and technically anything they receive over fiber channel, gets multiple paths. So I think in one of the environments we're looking at, we're getting 6 different paths for each of the disks. So that means you get 6 different dev SD something devices for the same disk. And to boot that correctly, you want to detect that and then set up multipath in Linux, so that all 6 devices can get merged into one, where if some of those 6 go down, the kernel doesn't care and can just fall back to the others. We've had multipath support for a while, but only for additional storage coming online after installation. So it took us a little while to actually get everything going correctly in the initRD and early boot to allow for the root disk itself to be on a multipath device. So anyway, that took a few weeks to get that done, and we finally merged it. So it's still all of that stuff is multipath related. Few tweaks on how we report disk device IDs. We were kind of incorrectly picking up LVM PVs as the primary device IDs for some disks in the storage API, so that got resolved. Same thing during installation. We were sometimes picking the wrong device ID to report as the target disk during install. That's been changed now, so we've got a more consistent output, which helps with our tests that were a bit flaky because of that. Some more follow-up on the multipath handling. Also a tweak to the recovery prompt. We had that issue where the recovery prompt would not really give you any feedback if the password is wrong, wouldn't really let you try again. So that's been fixed now, so that it's a bit better, and you get to actually be asked to try again. Then we had a community contribution adding support for Tailscale services. So that's been added to our existing Tailscale support now. More rebuilds, then some fixes both to the new Tailscale service logic, as well as a crash in the kernel config API. Then added support for the QED firmware. I don't remember which. I think it's like QLogic NIC or something like that. They did some firmware added to Incus that needed some other changes in the Incus, added to Incus OS. That needed a few changes to the rest of the Incus OS build mechanism to allow for Linux firmware to provide artifacts both to the base image and to the GPU support image. So that was done, and we got that merged earlier this week. And Smart PQI was another, that's another driver we need for some generations of HP smart arrays. So that's been added to the initRD now. And I think we're getting onto the last page of changes. I think, yeah, it is. More tweaks to the multipath logic, adding some delays when we detect a Cisco fiber channel over Ethernet driver, because we noticed it takes about 5 or 6 seconds to enumerate all disks on it. And if we don't have any delay in the initRD, we actually fail to detect multipath and we boot with a single path, which is not good. So I did that. More test fixes, added some automated testing for multipath as well. There was an interesting issue where so we've got an API to pull the systemd log, and we use the JSON encoding of the systemd log for that, but well, the journal log effectively. One thing that's weird is if you get non-ASCII characters, then systemd will switch the format of the log message from being a string to being an array of floats, well, array of integers technically, but then JSON returns it as an array of floats, and representing the character code. And we didn't have support for that, so we're actually skipping a bunch of log messages that had special characters in them or escape sequences in them. So we fixed that logic now in the client, on the client side, to correctly decode those messages by turning them back into a proper slice of bytes and then turning that back into a string. Some tweaks in the at API level to kind of align the structure of all of the service configs. We had USB over IP that didn't have an enabled flag, and then Tailscale didn't use a substruct, like a separate struct for its config. It was just a nested struct, so fixed that to align their behavior. Then we landed support for Netbird, so that came also from a community member. Did some tweaks, cleaned it up, and then did that last night. Incus 622 added support for logs volumes, and Incus OS normally automatically sets up volumes for both backups and images. So at night also does it for logs in the same way. And what else do we have after all the Netbird stuff? I guess all of that was Netbird. Yeah, then a small set of fixes I did this morning, actually related to Ceph, where udev was incorrectly creating symlinks for volumes coming out of VMs. So if you were running an Incus VM that was itself running Incus OS, that could lead the host system to ultimately mount that VM's EFI partition, for example, on the host. And more annoyingly, even go as far as applying an update to the VM's EFI partition instead of the host's EFI partition, causing a whole bunch of weirdness. So I did some logic to ignore RBD, NBD, and ZFS devices in both LVM and in general throughout UDEV within Incus OS. So that addresses that issue completely, at least in my testing. And that's basically where we're at. Again, like Incus OS has grown quite a bit. We've got a lot of feedback on the forum and on GitHub. We've been landing a bunch of quality of life improvements and some larger features. If we go look at our milestones right now for what we're currently working on, so that's the milestone for what we're planning on doing by the end of the month, effectively. There's some more testing we need to tweak, and then Matthias is currently working on ZFS improvements, so supporting converting from RAID 0 to RAID 1, support for adding special VDEVs, support for doing mirroring of logged devices. So there's like a cluster of ZFS related stuff on top of, there was another thing on the forum that was ZFS related that we also wanted to handle. Oh yeah, handling of creating a Z pool with mismatching device sizes, which requires a forced flag to be passed. So adding support for that as well. And then we've got more storage related stuff, specifically around like more complex selection criteria for the target disk during install, and also allowing for a machine to get reinstalled, which is currently not possible. And then we've got a few more features. So yeah, reasonably busy this month with Incus OS. But what we're actually talking about for this live stream is not scheduled for this month. It's actually scheduled for May because it's a bigger chunk. And this is specifically about allowing for like a full turnkey deployment of Incus. So right now, if you get Incus OS and download an image and install it, it will get you a pretty well-configured standalone server. It includes even using external authentication through the forum or that kind of stuff out of the box. But if you wanted to deploy a cluster, we've got instructions on how to do that, which works well enough, but doesn't really provide you any of the support components. Like if you want to deploy Incus as like a functional cluster with like 3 servers or something, and you want all of the features to really work, you also want to deploy a local identity provider. So that's an OIDC provider of some kind, can be Citadel, Authentic, Keycloak, forgot, there's like a bunch of others we've been using. It needs OpenFGA for authorization control. You kind of want a logging platform, so either like a central syslog server or something like Grafana Loki. You want a Prometheus or at least OpenMetrics compatible time series database server to pull in all of the metrics for both the system and Incus itself. And then you want to also deploy Grafana to do some dashboards and handling on top of that. Then you want a reverse proxy, something like a JProxy or Traffic, to handle your ingress into the cluster and into those support services. And then you've got some additional fun if you want to also do distributed storage and networks. So that's where Ceph and Oven come into play, or also Linstore if you want to use that instead. So quite a few moving pieces there, and we can obviously provide, tutorials on the forum or link to examples of how to deploy those by hand, but that's not that user-friendly. We really want to get to the point where someone at home who just wants to get the virtualization platform up and running quickly so they can go and run stuff on top of it, can do so without having to learn all of those technologies and their config files and whatever independently. So our general approach has been, our general plan has been to add another field, like another config option effectively to Incus OS that says, I want Incus initialized, but not just initialized. I want it fully set up with like all of those services. And then make it possible to go from there to joining more servers into the environment and getting effectively a HA cluster with all of those services and have all of that running with just effectively download an image, run it on 3 different machines, go in the UI, click a few things, and off you go. That's the end goal. That's why this is not a we're gonna do it this month type thing. There's a bunch of moving pieces that need to be looked at independently. And specifically for this live stream, what I'm looking at is Ceph, because I've done Ceph and Oven manually recently on top of my own clusters. I also have the other components, but they're usually centralized in a data center, not even in my local environment. But Ceph and Oven are effectively local to the cluster, and they're therefore pretty good targets to see how we would want to deploy them and manage them moving forward. Just looking at the chat here. Okay, so yeah, just comments like about learning about Incus OS, Incus in general, and looking at what we can do with clustering. So yeah, let's get you maybe a quick overview of what it looks like to run Ceph. So Ceph has a bunch of different components, and there are the names there like OSD, Mon, MGR, MDS, and RGW. They're kind of the main components. There's more, and some of those we don't actually need right out of the gate. The ones we do actually need at minimum would be Mon, so that's the Ceph monitor, and OSDs, which are for the disks. So to get a minimum size functional Ceph cluster, you basically are looking at running at least 3 monitors. Like for HA, you would want 3 monitors, and you would want also 3 OSDs, 1 per server. That's kind of your minimum size. You can go up from there to insane sizes, but if you want Ceph to be happy and fully redundant, you're looking at 3 drives across 3 servers, and then 3 monitors, also ideally spread across 3 servers. In the past, what we've done with things like Incus Deploy, or even prior to that at Canonical with LexD and Microcloud, was that we would run Ceph and Oven services directly on the host. So they would be running on the physical servers, and they would manage there. I think that was a bad approach. I think the approach I'm taking now with IncusOS is the approach that makes the most sense. IncusOS is all kind of about, cattle over pets. We don't want servers to be special. We don't want a deployment of 10 servers to have 3 of them that also, by the way, those run the Ceph monitors control plane, like the Ceph control plane and the Oven control plane. Because now you need to be very careful about what servers can go down. You no longer are in a situation of like, okay, I've got 10 servers, I need to at least keep 3 for HA. It's like, I've got 10 servers, but I need to make sure that of those 3, only 1 can ever go down. Because if more than 1 goes down, then we take down the entire cluster. So that's the kind of thing you want to avoid, and that we've actively been trying to avoid with Incus OS. The way I do it these days, and I can actually show you what I've done in my production cluster, the one that's running actually in this in my server room in this building. I've got an equivalent cluster in the data center, but I'm gonna start by just showing the one I've got locally. So if I switch my remote to the internal project of my local cluster. So it's an Incus project that's got some restrictions applied to it. Specifically, like it's set to not be allowed to use any of the distributed storage stuff. It only has access to, actually those are the old names. I need to fix that config, so let me go and do that. Because I've renamed a bunch of stuff. So what we actually don't want to allow is remote HDD and remote SSDs. Those should not be allowed. So now if I look at the storage list, takes a while. Okay, it now shows that this project is only allowed to use local storage. That's kind of what you want for internal services. You don't want things, at least At this stage, I don't want those to be stored on distributed storage because otherwise we might get a chicken and egg issue. Other restrictions, like it is a restricted project, it does allow some low-level access, it allows privileged containers, there are some different things, but it's mostly to prevent accidents by just creating containers or VMs that can't be started in the event of a cold start. Like one thing we need to make sure we can always do is if the entire cluster loses power and then power comes back, things need to be able to go back online. And then if your storage or network is dependent on containers, those containers need to be able to come back online on their own prior to anything else being able to come back up. Incus does have that mechanism in the background to check whether networks and storage pools are online. So it will handle fine with the situation of storage and network are dependent effectively on itself, because it will start anything that doesn't depend on it. And then it will retry the rest in the background every minute or so, eventually being able to bring everything back online. But you still need to be careful to not accidentally use any kind of shared network or shared storage on any of those instances, because then you would lock yourself out effectively. So that's why I'm using a restricted project to mostly prevent accidents. It also, like effectively on the network side, same thing. It only has access to a single network, which is a physical network. It doesn't have access to any kind of other networks or anything, again, to prevent accidents. So what is that project actually running? So that's the list of what's actually in there. You can kind of ignore the debug ones. The containers I'm using to debug the Incus OS host if I need to. So I'm using some trickery there to be able to get onto the Incus OS host, even though it's running on physical machines, for debugging purposes. So you can ignore those. But then you've got the piece we actually care about for today. It's the Ceph side of things. So you can see I've got 3 different containers called Ceph Central, and they're running on 3 different machines. And then I've got 1 container per machine that's called Ceph OSD with the name of the machine. Now, if we go look at what's at the actual config for these guys, Ceph Central is basically just a Debian 13 container, and it's just attached to the cluster internal network. So that's basically it. Like inside of it, it's configured with static IP, static everything, so that we don't depend on a router being able to hand out IP addresses, since the router itself might be a container that's not up yet. So we just make sure that all network is configured statically in there. Then, so that's for the Ceph Central. We've got 3 of those, and then in there, what's effectively being run are all of the Ceph services. So you can see it's actually running the monitor as mentioned, and then MDS and MGR, which are not, manager is for the kind of background actions and monitoring and that kind of stuff. MDS is the metadata service, which is actually used to run Ceph file systems. And I also run an RBD mirror because I've got Ceph clusters both here in my home rack, as well as in the data center, and they're doing trust replication of critical volumes, so that if either of the environment goes down, I've got a replica of that data effectively live on the other side. So those services are not tied to any disk or anything. They are effectively containers that can float around, which means if a machine gets well, actually currently it's configured to be stopped, but it could actually go back to migrate at this point. Just that was during setup of the cluster. The idea is that when maintenance is going on, I can evacuate any of the servers in the cluster. I will still have a majority of the Ceph control plane running, and I can even migrate that existing Ceph control plane container to another machine, set it back up there, so that I can actually keep even the 3 copies running as much as possible. So that's for the Ceph control plane, and then we've got the OSD. So that's for the disk side. Those are very much tied to specific servers. That's why the server name is even in the instance name. If we go look at what that does in live, there we go. So again, Debian 13, it's running the same Ceph build. It's attached to the same cluster internal network. Also worth noting that cluster internal network is actually, in my case, it's a VLAN with a high MTU. So it's got an MTU of 9,000, which makes it just that much faster for storage traffic like Ceph. So that's running. Running Debian 13. It runs a bunch of OSD processes, and we can see it actually gets past 4 different drives into the container to then be used as OSDs. And I'm making use of the fact that Incus OS can do disk encryption of RAR disks these days. So Incus OS itself encrypts all 4 SSDs, and then I pass the decrypted volume into the container to consume as an OSD. And that means my host system, my host Incus OS system, is fully encrypted using the TPM to unlock. And then once that root storage partition is unlocked, it gets the keys to unlock all of the extra disks, all of the, in this case, all of the Ceph OSDs, and also unlock additional storage from that's on an extra Z pool with a couple of enterprise drives. We can actually show you that too. So if I do admin OS system storage show, or let's do the first server, so Trilak. If we look at what we have, we've got 2 storage pools. So one is called hotplug NVMe. It's got a couple of, actually those are the disks. So like, yeah, let's look at the pools instead for now. We go down to the pools. There we go. We've got one pool, which is hotplug NVMe. It's got a couple of enterprise drives in it. And then we've got second pool, which is the local pool. And that one just has some like local SSD, and that's it. Now, if we look at the actual list, we're going to see a bunch of Samsung 2 terabytes SATA SSDs. And those, if we look, they're marked as encrypted true. And then there's encrypted ID being exposed. So that means if we're encrypted through Incus OS is in charge of the key, it will automatically unlock them on boot, and then we can pass the decrypted volume into the containers. So effectively, each machine has the same config where it's got 4 disks attached to Incus, to an Incus container, and then Incus runs the OSDs on that. So if we go inside it, oops, I want the name, not the device path. There we go. If we go look at what's running in there, we can see Ceph OSD 1, 2, 3, 4. So that's kind of the same layout I would want to see be replicated when we start deploying Incus OS with those kind of services automatically. The thing I don't want to see replicated is the way I've set things up, because as I've said, like, those are 2 Debian 13 containers, and they run normal Ceph packages, and they were configured effectively by running Ansible centrally. That is not gonna scale. I don't want to have every single Incus OS home lab cluster or anything out there needs to run Ansible, need to apply package updates across all of those containers. That is not gonna really scale. I want the containers to do the same thing that they are here. I don't really want to change that part, but I do want to change the actual image and how it's, like, its life cycle and how that works. Same thing with Oven. That's kind of out of scope for today's live stream. But Oven kind of has the same thing where we need to run a cluster of 3 Oven central services. It's like a couple of Oven databases in each. Oven uses Raft, so it also needs consensus. It also needs at least 3 to form a cluster that's actually HA. And so it's got most of the same issue that Ceph does, in that we want to run that control plane, also spread it across the cluster, also make it HA, and not need the user to use Ansible and do package management and all that kind of stuff themselves. So what is kind of the solution to deal with this stuff? Well, the plan is to use OCI containers. So instead of running full-fledged full-fledged system containers like I'm using here, the idea is to use OCI images published by the Ceph project, so in the case of Ceph, to act as the base for all of the control plane and OSD's containers. And then effectively have probably, I mean, we need to check what the state is handled, but effectively storing the state in a custom volume that's attached to the instance, making it so that the root of the instance itself is effectively completely stateless, and allowing then for Incus OS to go and update things by just rebuilding those containers one at a time to the latest image. And that's effectively all you need to do to be able to handle some of those updates. There's slightly more complexity, like Ceph major version updates often need some user intervention. So there might be some more automation and steps we need to put in place. But as a general idea is that you should be able to basically tell any of the Incus OS systems in the cluster, hey, I would like Ceph to be upgraded. And then that can just go look at the cluster, figure out that you've got those 3 containers. We can put some user properties on those containers to provide extra metadata and details. And then based on that, Incus OS can just go and effectively rebuild them one at a time, checking that everything seems to be online, and off we go. What we can't have really in any of those kind of deployments is centralized state. We need to make it so that you can go to any of the Incus OS servers in the cluster and tell them that you want to update something, or tell them that you want to deploy something new, and they need to be able to just go look at the cluster and get it done. That's going to be pretty critical to effectively have something that can scale to any sizes we want, and that doesn't have any kind of bottleneck of, okay, yeah, everything is HA except for that one container that has all of the keys and does all of the management effectively. So that's the idea. I've not actually played with the Ceph OCI image before, so that was going to be my first step. Is let's see if we can assemble effectively. First of all, getting it running on Incus, and then see what needs to be done to tell it what daemons to start, and then what needs to be done to actually initialize that environment so that you get an initial monitor and then can join a couple more monitors into it, and then can join OSDs into it. So that's kind of the idea. That's what I was gonna start with this live stream. Not gonna use this production cluster obviously for that. That would be a bad idea. So let's switch to a development cluster instead. And this development cluster actually already has a internal project because it's running a lead store controller and an oven central service. Not HA for either of those environments, so that's not really what we'd like to see, but it's functional for that particular cluster right now, just for testing purposes. So what I want to do right now is effectively create my my Ceph Central 010203 from the published Ceph upstream image, and then try and get that behaving the same way they do with the ones I've deployed by hand. Probably taking a bunch of notes for that. Thankfully, this is on video, so I don't really need to take much notes. I can literally go and watch it back to then figure out how to automate as much of that as possible. Again, in a way that can be done without needing centralized state. To be clear, there's a bunch of stuff we can do without centralized state. I say centralized state in the sense of without having a central management container, or having Incus OS itself have to store state, because Incus OS itself is not clustered. It can't make sure that this state is spread across the cluster. Conveniently, Incus does have a shared database that can store details. So as mentioned, we can totally set a bunch of user.config keys directly on some of those containers to provide details about their configuration and what they are and how to connect to them, and even credentials. If we need something that is more global than just per container, we can set config keys on the project instead. If we need something to identify config on the entire cluster, we can set config keys on the cluster itself. So there's a bunch of things we can do there to effectively use the Incus database as our central repository, like central configuration repository to an extent. I'm just gonna try and keep that to a minimum. Like I don't necessarily want to end up, we could in theory store, like a Terraform state and an Ansible state, and then have Incus OS like create a temporary container and run actions from that and deploy everything that way. It would be possible. It would be extremely hackish and also probably still pretty error prone. So not something I really want. The other nicety of using effectively OCI images is that it's easier for someone to run effectively in an air-gapped environment where you can just have one server storing all of your, like running as, acting as both an Incus image server and as an OCI registry, put all of your images there and then pull from that. That's more relevant in kind of the enterprise deployment side of things, but it's nice not needing connectivity to the Ceph package repository and then the Debian archive and then a whole bunch of other services that you need just to be able to run your deployment. Anyways, so that was a lot of me talking. Let's go look and try to do some stuff. So if we look for Ceph container image, I think that should give us the documentation. Yep, Ceph doc container images. They say that effectively the image is stored on I think that's Red Hat's registry. I don't know if they've got a nice web view similar to Docker Hub anymore. Let's see, what do we get if we go there? Just gets me, okay, Red Hat shows Ceph /Ceph. We can do, so Incus won't have any problem pulling from that. I was just checking the structure for like the tags and everything. How does that kind of look like? Yes, we can look at the tags here. So you can do a major release, in this case v20, and that would get you the hash 120. So the same hash as this. Okay, so if you do the major, just v20, that will get you the most recent stable build. Effectively, you could be v20.2 or v20.2.0 to be more specific. I don't know if they've got a generic get me stable thing. Doesn't really look like. What did they say in here? Did they say you need to pick your major? There are a few ways to choose. Yeah, there we go. Full version. So they say production could use that to pick very specific things. So Incus OS might actually end up doing that, where it can actually resolve the tag, like go and figure out what the latest one, pick that, and then apply it consistently so that we don't have slightly out of sync servers. That might be the way to go. But in our case, for this environment, I think we're just going to use the major and so do v20 to get us. What's v20? So I think I'm still on 19. Because 19 is squid. So tentacle, yeah, because I'm like, that would be T. They do in their code names are in alphabetical order. So like, what is T? So yeah, T is tentacle, which was released pretty recently, towards the end of 2025. Yeah, November 2025. So anyway, let's do the v20 and see what happens. First question here is, do I have the right remote for that? OCI, yeah, I do. Okay, so I already have a remote added to access that registry, so we can just go and do incus create OCI query and then Ceph/Ceph, I think they said. So that would be Ceph central 01. That's what we want to create. Let's try that. Did not work. Okay, what did they say? Did they say in the doc for how to pull those images exactly? Oops, wrong one. Actually, we have it here. Okay, so they basically say that should have worked. Okay. It didn't. So, or maybe, I guess I do need to mention the tag. Let's try the tag v20. Is that the issue? Yeah, it looks like it was. Okay. They don't effectively have a latest tag, so you do need to specify the major to get it, which makes sense. So I'm just gonna let it download, unpack, repack the image and see what we get. My understanding is that those images are meant to be used by Ceph with Ceph Manager. I think it's Ceph Manager. I forget that's the name of the thing. Let me just recheck. But if we go to back to the documentation here, yeah. So Ceph container images, and they probably mention what how they're meant to be used. So Ceph daemon base, necessary daemon dependencies, but okay, yeah, probably don't want that. Okay. Yeah, so they've got some variety of images. I think we're just putting the full one, which makes sense. My understanding is that those images are probably what they use these days for Ceph Adam is the name I was looking for, yeah. So Ceph Adam or Ceph ADM effectively deploys on top of Podman or Docker, and I think it uses those exact images. And then you've got Rook, which is the Kubernetes version of that, which deploys across a Kubernetes cluster. Obviously, neither of those will straight up work for us because we're kind of an in-between. Like we are clustered, but not Kubernetes clustered. So we can't use either of the tools as they are. It feels like Rook would probably be closer to how we want things to work. But we can hopefully just go and use the exact same images and then drive them most of the same way that either Ceph ADM or Rook would, and that should give us something pretty solid without us having to start maintaining Ceph ourselves effectively. So it's still generating. Okay, doing the unpack now, and what we need to check is what the entry point looks like. The nice thing is that we're going to be having automation around that. So there's no issue with us pushing a script in there. There's no issue, for example, like Incus OS can totally generate a new script and change the entry point to that script. We don't need the image to work completely verbatim. We can do some amount of light customization to it, so long as it's going to be the kind of customization that will not impact release to release behavior. Like effectively, if we need to inject a script to drive this the way Ceph ADM would, then that's perfectly fine. Because Incus OS will know to re-inject the script every time it does an update. It could even do it every time it itself updates in case something changes. So there's some flexibility there. We don't need the images to work perfectly for us with just environment variables or something right out of the gate. All right. So that's interesting. I'm looking at, first thing I saw is the entry point. So entry point is set as bash. So it's literally started as a long running type instance, if you wish. It doesn't have like a clean entry point for whatever service you want. That's probably what Ceph ADM would do. Then we've got some details for the version that's being deployed. So it's effectively sets environment variables to tell us that this is Tentacle. Ceph OSD flavor, I don't know what the values for that is. I don't know if any of that stuff is documented. Since it's usually driven by Ceph ADM or by Rook, I don't know how well that's documented. Okay, so it's documented in some of the Rook documentation, looks like, which is good. So we can go and look at that. This is like on the chain guard images, but I think that just shows us the default values more than anything else. Can go look at that, and then here, yeah, same thing. So it just gives us the same thing as I'm just saying, which is like the default values, but doesn't actually really describe what any of those things are. So okay, fine. We're gonna have to find out for ourselves. So let's try and start that. I'm not sure what happens if you set the entry point to bash actually with Incus, so I guess we'll find out. Like, is it staying online? Yeah, it is staying online. Okay, so we can see it running. It's got an IPv6 address automatically from the kernel. If we go in here, so there's nothing running because obviously its entry point is just bash. Now we can go see kind of what it has. First question is like, what is it based on? That looks like Red Hat. Yeah, CentOS Streamline. Okay, that kind of makes sense. I mean, Ceph is developed by Red Hat after all, so that makes sense. Then we've got the different comments there. And yeah, we see the different daemons. We've got monitors, managers, MDS, OSD. Do we have RBD mirror and everything too? Yep, we do. So it looks like it's got every single tool that you might want. Now the question is like, does it have any scripts to set things up? So that's just the base image stuff. Like I'm not super familiar with what Ceph ADM does. That's the part that might be interesting, is to actually go dig into Ceph ADM to see how it consumes that. Like how does it set it up? Potentially just running Ceph ADM actually just in a VM, making it deploy a minimal Ceph environment and then go look at what it did as far as the Docker configs. Like I fully expect that we need to put varlib Ceph on persistent storage. Is it even pre-created? Yeah, it is. Okay, so varlib Ceph, all this stuff needs to be moved to persistent storage, because if we rebuild the domain, if we rebuild the VM or the container, we need that to persist. I don't think there would be any pre-created anything in there. No, there isn't. Actually, one thing that would be interesting is, can we get the a Docker file for how they put together that image? Do they document that anywhere? Because that would be the other thing that's interesting to see, if they've got any scripts or anything in there already. Yeah. Okay. Yeah, doesn't really straight up link to where those would be defined. So let's go look at Ceph, the Ceph org on GitHub, if we can, if there's anything obvious in there. CSI driver, go Ceph binding, Ceph NVMe over fabric. It might be the Ceph repo itself that might actually be directly in there. Yeah, that's okay. It might just be in the main Ceph repo, maybe. Let's see. Do they have anything container related in there? Container file, build, okay. So that takes the CentOS 9 image. Okay, it's got the arguments and stuff. It grabs, so that's probably the. Okay, Ganesha OSD flavors. Just trying to figure out from base image, Ceph. Okay. Okay, that's what we see. So the entry point there. Okay, pipe fail, source major case. Okay. Just trying to see where it actually starts installing. So we got DNF installing EPEL, installing the Ganesha repo for the NFS stuff, IncusOS, downloading there, Ceph repo is being added here, copper repos, then updating, then installing all the packages. Okay, so that's all the stuff we saw is installed in there. That's fine. Okay. Just checking if there's anything else interesting. So it tweaks some UDEV stuff. I don't really, so one of the things that Ceph really loves using LVM inside of Incus containers, especially in privileged ones, really not a thing. So I've not used LVM, I've just been using Ceph OSD directly against the block storage. That's probably what I would be doing here too. Okay. Yeah, so there's nothing, they did not seem to be injecting any kind of script or anything to make initial setup easy. So we basically need to, and I'm assuming that's because FADM effectively handles all of that stuff. So we might need to just kind of do it ourselves. So effectively, during initial deploy, create the 3 containers, then pick the first one, generates the initial keyring, generates the initial mon map. So that's the 2 kind of artifacts you need to bootstrap your Ceph cluster. And then, so effectively have Incus OS itself puppet that through the Incus API to get it going onto the first one. And then once it's done, join the other 2 into it. At which point there's nothing that will make them special snowflakes or anything. They're not particularly special anymore. All of their storage will be on persistent storage, and it will be possible to just rebuild the container freely, which is what we want for maintenance purposes. And Incus OS will not need to actually store any secrets or anything because the keyrings and everything will be spread across the 3. So it seems like we'll probably go that way with effectively Incus OS, including some scripts for the initial setup, and then another script which gets turned into the entry point for those containers. So once they're deployed, the entry point would flip to no longer being just bin bash, but being something like /startup or whatever being the script. And that script can then look at its environment variables to know what it's supposed to be doing, like effectively what services are enabled. I think at the beginning, we will just always enable monitor, manager, MDS, potentially even RBD mirror, why not, across all 3. And just have a script that starts them all up, that does, like the thing is that like they're using, I don't think they're putting any of the tiny init systems in there. Like do they have like full-fledged systemd in there, or what do they have? There's full-fledged systemd. I don't know how well that works to just run that. Like do we have has been in it? Yeah, okay, so we do have, so there's a full-fledged systemd that's installed in there that's not being run. We might be able to use that and like literally start an application container with full-fledged systemd as the init system, and then let it run the Ceph services. If are they even defined in there? Oh, well, yeah, there's no systemd running, right? Let's do Ceph service. Oops, grep. Yeah, all of the units are there. So it could actually be switched to straight up running systemd. And then enabling those services after they've been initialized and letting things run basically the same way they do in my Debian container, with the main difference being that this container already includes everything with an optimal upstream build. And so long as we make it effectively be stateless outside of the valid Ceph, then we can rebuild on any version we want, can easily scale it, can easily upgrade it that way. So I think that's basically the plan. Let me just do a tiny bit more poking around in this live stream. I think I'm just gonna try and get a Ceph monitor bootstrap by hand. But then more of the research I'll probably do kind of off stream, and we can pick things back up next week, see where we're at. Because like it's basically gonna be writing a few scripts to actually do the initialization kind of by hand. Then once we get that going, then finding where we want that logic to land within the Incus OS management daemon, and effectively get an API where I can just be like, hey, I would like Ceph deployed on my cluster, please, and have it deploy automatically the Ceph daemons, the central daemons, and then being like, okay, I would like on this server, I would like those disks, or on this server, I would like those other disks, and get the OSDs kind of up and running that way. Most likely for the OSDs, I think we would do it on a per server basis. We need to use the Incus OS API of that server to effectively say, okay, you've got those local disks. I would like those to be exposed to Ceph, and then it will either create or update an existing Ceph OSD container to make that happen. Okay, so I said, like, I'm gonna go and try and bring up a Ceph monitor by hand. I've not done that in a while because I tend to just use my Ceph, the Incus deploy stuff we've done a while back to just do that. So you can do it in one of two ways. One way would be to look at the Incus deploy code and just kind of replicate it. The other one would be to follow the Ceph documentation for manual deployment, which I think they still have. So if we look for Ceph, not manager daemon, where's the monitor? Trying overview, not really. Okay, fine. Installing Ceph, other methods, manual install. Okay, get the packages, get the things, Ceph mirrors, Ceph containers. Deploy custom manually. Monitor bootstrapping. There we go. That's what I need. So bootstrapping a monitor requires a number of things. You need an FS ID. I mean, that's just a UID. That's easy enough. Cluster name, a bunch of other things. Okay, fine. So once you get on the system, get a UID, and then you need to generate an initial ceph.conf. Okay, we can do that. I mean, what I can actually do is just show. So if I go here, I can show my production environment. So if I go here, exec into Ceph Central 01, I'm going to go look at what my full Ceph.conf looks like, which is basically this. Do we have VI in here? We do. Yeah, for an application container, they put a lot of stuff in there that I would not expect, but that's fine. So I think, yes, as far as the persistent storage, we're going to want valid Ceph and etc Ceph to be persisted. I should actually just do actually that in the different documents. I'll just start with some notes. Persist etc Ceph and valid Ceph. Okay. What the terminal is. Okay, there we go. So let's just create a new config. The client config here, not relevant at all, because we're not gonna, that's really on the client side, and for us, the client side is Incus OS, so that's just not relevant in the slightest here. So we probably want something like this. The network here, public and private network, would be probably not something we actually need in this scenario. It's more useful if you have multiple IP addresses and you need to select the right ones, but we are literally shoving them all on a dedicated network, so that's not really a thing. Then IP address 6789 for the initial monitor. So first comment that they don't actually have. Interesting. Remote dev cluster 01. To figure out its IP address, and it doesn't give me the usual tools to get that. So let's go get it from Incus instead. All right, so let's take that. And so initial monitor would be like this. It's called Ceph Central 01, and then we need a new FSID. Do we have UID gen in there? We do. Excellent. Here we go. Okay, so that's our Ceph.conf, initial, most basic Ceph.conf we can do for a single node Ceph at this point. So that's what that looks like. And they actually said just do hostname, no port, so we can do that. Like my logic for Ceph is pretty old syntax, so things have kind of evolved since. We might actually be able to just do it like this, maybe. Nah, it might still get confused. Let's keep the square brackets just to be safe. Initial node, members. Yeah, so we've got all of that. You may use IPv6 address instead of v4, but you must set them as bind v6, IPv6 to true. You do? I definitely don't in... Oh, but I might have done it in the global config. Because I definitely don't have the bind v6 here. But that's not to say it's not actually set somewhere. Yeah, there you go. Bind v4 false, bind v6 true. Yeah, okay, fine. That will also vary based on the environment, but our cluster internal network is usually IPv6 only. Most users won't actually notice that anyways because they don't need to access it, so it's fine. So we're just gonna force no v4 but v6 enabled. So do it like that. That should be fine. Okay. Then we need to generate a keyring, so that's what it does here. It uses Ceph OCI tool to create a initial monitor keyring. So let's do that. Good, it's got the tool we need. Generate an admin keyring as well. So let's do that as well. And that puts it already at the usual location for the admin keyring. Then generate a Bootstrap OSD keyring as well. Sure. Okay. And then add generated keys into the initial mon keyring. Sure. Yes, it's importing the admin keyring in, and it's importing the Bootstrap OSD keyring. Sure. Oh no, that's fine. Let's change that. And then we generate a mon map. So that's the initial list of the monitors. So we just need to add the local host name and then its IP address. Again, not sure about syntax for IPv6. Let's just assume square brackets. So I'm gonna go and take that IP address. Just adding a missing digit here. And then the FSID, which I don't remember if I ever dumped. So I'm just gonna go and pass that stuff here, get the FSID. Okay. Like that. So that's actually a few more nodes. Add to cluster config. Well, either project or cluster config, it doesn't really matter. We'll want like a user.ceph.fsid to just make it easier to, like, we don't want to have to, every time we want to join a machine or configure a machine, have to go in inside of the Ceph cluster and run some commands to get the data out. So same thing, like the user Ceph FSID will go in there, and I think user Ceph dot keyring dot admin would also go in there. So the admin keyring, like, it's not the Ceph keyrings are actually pretty convenient. They're not large. So the admin keyring, the only thing you actually need is just the key here. You don't need the rest. So we can very easily put that in the Incus config for the project, and then we can use that as a way to just know instantly what we need to do to configure any of the other systems. Same thing for the Bootstrap for the OSDs. We don't need to pass to go and access the main keyring to the main container to get the keyring and then put stuff back out. We can just store the Bootstrap keyring itself, which it generated. Bootstrap was here. We can just put that key into the config. So, but we'll have to check some of the permission stuff, because basically keyring dot bootstrap man. Some of the permission stuff can get a bit weird, since we might want to limit we'll have to see. It might make sense for the OSDs to be able to self-register, in which case they need more permissions than the Bootstrap OSD keyring is allowed to do. Given it's the same tooling that controls everything, it can also just use the admin keyring and just perform all of the actions as admin, and then use that to generate the per OSD keyring, so that the OSD itself doesn't have permissions it doesn't need. So we'll see. Like, effectively, since Incus OS acts as the orchestrator for a bunch of that stuff, it doesn't really need all of the permission split, since it can just get root into anything it needs anyways. So we can potentially make our life a tiny bit easier on that front. Anyways, so we've got our initial mon map, initial keyring, and yeah, after that you need to actually set up the storage for it. So usually the cluster is just named Ceph. That's the most common name. And then host name would be, actually, I don't, what am I doing in mine? For that syntax? Oh yeah, okay. I'm like, this is gonna be redundant since the container is called Ceph Central 01, but yeah, that's exactly what I did in the other case, is that it does name it Ceph, which is the name of the cluster, dash host name, which is Ceph Central 01. So you end up with a bit of a redundant name there. Okay, so this gets created, and then I can do the initial population of the monitor on disk storage effectively. So I can run that. Make fs. So this is Ceph Central 01, mon map keyring. Okay, so that's good. That will have populated that Ceph folder here with an initial database. And then you could go and set more config keys and more stuff. Don't really need that. And then they say to use systemd to actually start it. So at that point, we've done the initialization and would normally go in and I mean, normally I would actually do an enable now or something syntax instead of start, but you would want systemd to handle starting this thing up. Obviously, that's a bit of a weird one now because there's no real, like this is an application container. So if we wanted to switch to systemd, we could, but I would expect bad things to happen, like a bunch of services do not start correctly and some other fun stuff. I mean, we can try to enable it anyway. So it's cephmon at Ceph Central 01, I think would be the unit. I'll just check what I have here. Cephmon at Ceph Central 01, yeah. So we would want to enable that. So it now marked it as enabled. Obviously, no systemd, so we need to go and change that and see what happens. I honestly have no idea what's gonna happen if we just put the entry point to systemd. That could be entertaining. Let's see. Like for one thing, it's like, what else is enabled in that systemd? Like, is it gonna try and run network manager and networkd or resolved or whatever? I have literally no idea. So let's see, has been init. So that would have it run systemd. It could just crash immediately and not even give us a show. Oh, okay, it's running. Let's see what it did on the console. Okay, so systemd started. Not much failed, to be honest. It failed to start RPC, the NFS RPC service. That makes sense. You need privilege to do that. You wouldn't be able to do it in a privileged container. But that generally worked. Now, if we look at what failed, we can see, yeah, this one unit failed, the rest is fine. Its amount, I would probably, like if we wanted things to be clean, which honestly we don't really care. But if we wanted them to be clean, I would probably mask that one to just take care of it. Now, what is it doing? It's running journal the udev RPC bind, Ceph crash, broker. It's running everything except what it needs. Like it's not actually running our monitor. Okay, it shows failed. Let's see why. Journal CTL, cephmon. Why did it fail? Okay, it failed repeatedly. Opening mon map, mon data directory, valid. Permission denied. Okay, so that's, we didn't fix the permissions hard enough, I think. Let's just fix that. So valid Ceph should be owned by Ceph. Then reboot and see if things work any differently. Python Ceph core utils. Maybe I'm blind. I'm not seeing them. Oh yeah, I'm blind. Okay, the monitor is running. Cephmon is here. Cool. Ceph status up and running. Okay, so we do have Ceph working correctly. There's a what's the enable messenger 2 command? Yeah, that cephmon enable messenger 2. Not sure why it doesn't do it by default, but whatever. The global ID reclaim is another one that you usually want to change. not here, in the config, what's the config? Reclaim. Yeah, there we go. So Ceph, there's going to be like a bunch of config keys that also need to be applied effectively post initialization. This will be one of those. Like it completes the byte, but doesn't do it by default. I don't know why. Set, I think it's global. We need to do the scope and then the key and value. Yeah. Yay, health. Okay, so we do have this effectively up and running as a single server. Joining more would then effectively have you set up the same container the same way. What's actually interesting is that systemd basically just worked. So that means we could just deploy those containers with sbin init as the entry point from the start, and then interact with the system, including having systemd in there. And yeah, put etc Ceph, valib Ceph on persistent storage, and then just use the Incus storage API to push a bunch of files around for the keyrings and whatnot, and initialize the cluster that way. So I think that's probably what I'll work on next, is just a bunch of scripts that do exactly that. And then once I'm happy that the scripts work correctly and they look nice and clean, then that's when we can move that logic into Incus OS behind some kind of API. And basically, yeah, be able to say, I would like a Ceph cluster now, please, and have it spawn the control plane and then attach some OSDs as well. That's looking pretty tractable. Like I'm surprised that they are using as fat an image as they are. It is convenient. It's definitely convenient. We can just run systemd in there and run a bunch of services. I don't know if that's what they do under Ceph ADM. Maybe. It sure would make things easier for everyone, I think. At which point, yeah, you just use that as a simpler image than what I'm normally doing with Debian, because you don't need to deal with packages. You effectively have everything pre-installed right out of the box. And if you move your state, so etc Ceph and valib Ceph over to persistent storage, then you can just rebuild it to whatever version you want and not have to care about it. So anyway, that's where I'm gonna leave it for this live stream, but that's looking pretty good. Should be able to go from there to effectively running all 3 services, or 4 services if we include the RBD mirror, in those different in those containers, and have a way to just rebuild it at will on whatever version we want, which will make it very easy for Incus OS to manage. And yeah, there will probably be like some discussions on, what's the best initial config for the Ceph cluster that we want to apply. But then if the user wants to customize anything, they can always get a shell into any of the Ceph containers and then use the Ceph commands to modify the cluster state. We'll probably put warnings in things like etc ceph.conf saying, do not touch this file, it gets generated by Incus OS, so don't mess with it. But since most of the Ceph config these days is managed through the built-in Ceph config mechanism, and that's stored within the monitor database, it's very nice and easy to reconfigure things and have the user tweak without starting to conflict with any of the stuff that Incus OS does. All right. Hopefully, there was a lot of rambling and looking at things more than actually writing code this time around, but hopefully that was interesting as an overview for where we're trying to get to. Ceph is the first one we're looking at, because last I checked, Oven didn't really have good container images we can just consume. So we might need to actually start building our own somehow. But Ceph does, because of Rook and Ceph ADM, both of them using those images. So that's an obvious initial target to go and automate. And then, once we've got Ceph and we're happy with it, we can try and look at doing Oven, and then we can look at also deploying Grafana, deploying Grafana, Loki, Prometheus, some kind of OpenID Connect IDP, deploying OpenFGA, deploying an HA proxy, deploying all that kind of stuff automatically, ideally all based on OCI images, so that it's easy to just rebuild them, update them by just wiping them out, rebuilding a new version, and not not need to care about state, not need to care about package updates. Effectively making it possible to just have an API through Incus OS being like, hey, I'd like all of my support services to be updated now, and just have it pick the newest version and apply it and call it done. All right. Hopefully the vision makes sense. Hopefully that kind of explains some of the gaps we're filling in slowly with this stuff. Like our goal is really someone goes on the website, downloads Incus OS, installs it on an initial server. They can even go through the UI to go and manage it. And they can draw that into a cluster, also still through the UI, download the install media for the other servers, boot them, they join the cluster. And just make that all very seamless so that you don't need a lot of technical know-how to actually deploy a fully HA cluster at home for a small business or the like. And you can focus on actually consuming Incus and enjoying what Incus provides as far as being a cloud platform that you can automate, you can run stuff on, instead of spending all your time babysitting the underlying platform and its support services. So anyway, again, hope that all makes sense. That's gonna take a number of weeks to start putting a bunch of those pieces together. I think the end of May current deadline we gonna have through the milestone might be quite optimistic, to be honest. We might have to push it more than that for the whole vision to be in place. Like we might have some initial abilities like, I already have a cluster, can you get me Ceph on it? And having that part be deployed automatically. Same thing for Oven, same thing for some of the other components. But for the whole thing to be like fully tied up and looking nice and having UI management for this stuff, it's probably gonna take a little bit longer. All right. Anyway, if you've got any questions about any of this stuff, or you've got useful pointers on how we should be doing some of that stuff, feel free to leave them down below in the comment section, or you can go on our community forum and chat with us there. We've got quite an active community of folks using Incus OS over there these days. So that's always a good place to hang out. Thanks a lot for watching, and I'll see you in the next one. Should be next week. It's probably slightly different time on Thursday, but yeah, usual live stream on Thursday next week. Bye.